Hello everyone. In this video we will determine the values of k that will make the function have two zeros. So we're going to focus on the concepts of the zeros of a quadratic function. And to start we need to consider the discriminant. And the discriminant is b squared minus 4ac. And since we're looking for two zeros, this needs to be a positive answer. So in other words, greater than 0. The a value is 4, the b value is negative k, and the c value is 25. And when we sub those into the discriminant calculation, let's make some room here, we end up with negative k squared minus 4 times 25. So that leaves us with k squared, and we're going to set it to 0 first, and then consider which values make it greater than 0, instead of leaving it as an inequality. So negative k squared becomes k squared minus 4 times 25. So 4 times 25 is 100. Times 4 is 400. So minus 400 equals 0. And then when we start to isolate k, we end up with k squared equals 400. And k will equal the square root of 400, which equals positive or negative 20. Okay, if we stop now, we have determined the value of k that will equal exactly 0, which means h at x will have 1, 0. But the original question wanted to determine values of k such that h at x would have two zeros. So we need to examine and analyze further these two possible solutions of positive and negative 20 for values of k. So let's continue with that. Let's take k to be greater than 20. And let's change the color here. So let's go with k being greater than 20. So let's go, for example, 21. And we sub back into the discriminant, 21 squared minus 4 times 25, which equals 441 minus 400, which equals positive 41, which is greater than 0. Therefore, overall, this quadratic h at x will have two zeros. And let's continue to examine greater than or less than negative 20, since we had two possible solutions here that equaled exactly 0. And now we need to determine when it will be greater than 0, which leads to a positive discriminant, which leads to two zeros for h at x. So let's continue with that, and let's make some more room here. And let's go less than negative 20. So we can go with a value of negative 21. That's less than negative 20. And subbing that into our discriminant, negative 21 squared minus 4 times 25 is going to lead us to the same answer, since positive or negative 21 squared will equal 441 minus 400, which equals a positive 41, which is greater than 0. And same conclusion, therefore we have two zeros. So overall, in order for h at x to have two zeros, let's make some overall conclusions. So, therefore, k would have to be greater than 20 or less than 20 for h at x to have two zeros. And that wraps up this video on solving problems involving quadratics and determining the number of zeros. And in this question, we started with h at x, and we were trying to solve for two zeros and what do the values of k need to be. And in our conclusion, you can see the overall work there, and I'll just scan through it again. The process, first we isolated the exact value that would equal 0, that's positive or negative 20. Then we analyzed if we had to go greater than or less than to lead to a positive discriminant. And in our work, we found that if k was greater than 20 or if k was less than 20, and we just used one example for each, the immediate number greater than or the immediate number less than, and we found that the discriminant became positive in those circumstances when k is greater than 20 or less than 20, which in turn means that h at x will have 2 zeros. Thank you for watching this video. Have a great day. You guys are awesome.